The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Okay,
Welcome everyone.
yeah, you can start, Bharat.
Welcome everyone. Thanks for attending all of the lecture series of the Siksha program. As you would have seen, this particular Siksha program is divided into two sessions. The first session is what we will be ending with today. This session would be dedicated towards any questions that you have with respect to the lectures which have been conducted so far, which includes lecture conducted by me or Dr. Satyajit or Professor Satyanath Chikrur, whoever. If you have any questions with respect to the same, today's session is dedicated towards answering those questions. So if you have any questions, you can start putting the questions on the question panel. But before that, I would like to invite Ashish sir to talk about the questions which were asked, particularly or information related to the exam itself. Over to you,
Okay,
sir.
yeah, thank you, Bharat. So, a document has been uploaded. I'm sure you would have seen it, which tells how the exam is going to be conducted. The exam will be conducted on Sunday at 11 a.m. sharp, and we are going to use a, proctor-based examination platform called Metal, which uses a secure browser. To download the secure browser, link is provided in that said document, and to make sure that you don't face any problems on Sunday, because there is no repeat. If you don't attend, you will not be able to appear for the exam again. So there is no repeat, it's going to be held only once. Hence it is important that your laptop, windows, everything is good to run that software. Hence tomorrow 10 a.m. onwards till Wednesday evening 4 p.m. Uh, a mock test is available, so you can take it anytime. And because it's a mock test, it will have some standard questions, aptitude. It has nothing to do with the examination. Those questions are only practice sessions, and you just appear for one or two questions, see how the questions are to be answered, and the marks are not counted. It just helps you in making sure that your setup, the MSB that you have downloaded, the OS that you have, the Windows that you are able to run that MSB software. On the day of the examination, there will be a proctor who will ask you to show your ID card. So all those instructions are there in the document that has been shared. Now comes the important part. If you would have seen the terms and conditions of this course, we have said that to appear for the examination, 50% attendance is necessary. So we have conducted 15 sessions. So those who have appeared, those who have attended 7 sessions, and that too they have attended for minimum of 45 minutes. The software has given us a report. The GoToWebinar has given us a report as to who all have completed 7 or more, that too 45 minutes or more. So there are about 120 such students who qualify for this. So they will receive an invite by today evening 8 p.m. to appear for the mock test. Okay, so please see your inbox, because it is the invite will come from Metal customer support or some such ID from Metal, and that link you should use to appear for the exam. So there is no time, it's not time bound. It is available for all more than 48 hours. Okay, not 48, tomorrow till Wednesday. Okay, so more than 36 hours, anytime you can take it. Just appear for it, take few multiple choice questions, and then you are done. And you, that will prove that you will not face any problems on Sunday. So that is the purpose of the mock test, nothing beyond that. I'll repeat again, marks are not counted, time, there's no time bound, it's not time bound. However, on Sunday when you appear for the test, you will get to answer, as is mentioned, you will have to answer 30 questions, maximum of 30 questions, and that time available is 40 minutes. So, and it also tells that though the test starts at 11, you have a grace period of I think 5 to 10 minutes to join. So suppose you join at 11:10, then you will get next 40 minutes to appear for the exam. So that is the way it works. So don't take any chance, appear for the mock test tomorrow, and then make sure that your platform is good to go. And on Sunday, 5 or 10 minutes prior to that, try to log in at 11 sharp. The exam will start. uh, Based on what has been covered in the lectures, the questions will be set on that, and there are multiple choice. And we have also mentioned 3 marks for correct answer and 1 mark for minus 1 mark for wrong answer. So try to answer the question with confidence so that you don't get any negative marks. So let me see if there are any questions. The question is, will the questions asked for commands discussed in the demo lecture session? So it will not be, it will be concepts that will be tested, Bharat, right? Not specific thing that what is the command you give to create a container, or I don't think that kind of, I mean, specific ones won't be
No,
answered.
we can't guarantee that. There might be some questions on that sense
But I mean,
also.
yeah, you basically, what I'm trying to say is, don't go too much deep into mugging up something. Okay,
Yes.
so it is more of a concepts that will be asked, and as Bharat said, just to check your alertness and how well you attended the classes. Some questions that could be tricky will be, yeah, exam duration will be 40 minutes. That's right, and 30 questions, 45. I think it is 45 if I'm not mistaken. Just refer to the document; it's mentioned there. I think it is 45 and 30 questions. I may have made a mistake in saying 40. In the Slack channel, in the announcement section, the complete 2-page document as to do's, don'ts, and every detail about that is mentioned, including the link to download the browser. I'm sorry, so secure browser, called as Metal Secure Browser (MSB). So if you have any questions, do ask them. Meanwhile, you can also ask questions about, as Bharat mentioned, about any topic that has been covered, and all the videos are available to you. We have sent you the link for registering, and all the videos, slides anyway were available on the Slack channel. So go through them. You have one good week to revise it, and I'm sure you all will pass with good marks. So do push it. I mean, this session is for clearing your doubts. So any questions that you had about what was covered in the past 14 lectures, do put them here, and Bharat and Professor Satyajit are here to answer them.
Yeah, you please ask your doubts and questions, and we'd be happy to answer them.
we get any idea about what kind of a questions we will ask? Maybe Professor Satyajit, would you like to?
Yeah, so basically the questions will be as Ashish sir was mentioning that it will not be something that you mug up and answer that. So it will be completely conceptual. So whatever concepts that we have discussed, uh, so mostly from that and MCQs, you will have options, four options mostly, and you have to choose one. So that's how it will be.
Yeah, all the questions would be MCQs. So there won't
Hmm.
be any questions where you have to answer in terms of sentences. There is a question, if I don't know if I understand it, hypercall interface.
Hypercall interface. What is the question? Q dot hypercall interface. What is the question? Can you elaborate on the question, please? Okay. Next question, I think.
Ashrut, would you be able to take this question? Ashrut, can you hear us?
Yes, I'm online.
So, Ashrut, there is a question. CPU is involved in W key QA preparation, and GPU is involved in ring doorbell. It is mentioned on the GPU Direct RDMA async slide 32 in the networking fundamentals. The question is couldn't understand. Can you clarify what is W key and ring doorbell means?
So whenever there is an RDMA operation initiated, it needs to first, create the packets and then create something called work elements. So WQE stands for work queue element. It's like multiple queues are generated and they are given to the adapter card. Okay. So once the data with all its context, with the brace transport header, which defines where the DMA data has to be put onto the remote memory. When it is kind of packetized, then a working queue is created, and then once it is ready, there is a process which needs to ring the doorbell saying that okay, I'm ready now, we can send it across. So that doorbell is nothing but the mechanism of saying that okay, the data, the queue is ready to take in the next set of instructions or data. Okay. So there is something called, work queue. There is something called completion queue. Once the work queue element is sent out from the sender side, the receiver sends out a completion queue. Okay, and once the sender receives that completion queue, it puts out the next element from the working queue. So it's a mechanism of sending DMA data over InfiniBand or RDMA based link and transport layer devices.
So there is a question on can we get access to the recorded session so that we can listen to those on which we are absent? Ashish sir, I think the recordings have been made available now, right?
Yeah, very much. I think that this is a big problem that we make announcements, we ask them to join those things, and they just don't bother, and then they ask. So that is what I always, I fail to understand this. that when things are given in crystal clear, unambiguous manner, what is the hesitation to read through them? Okay, so now it's too late. I mean, we have made it available almost 10 days ago. And if the student doesn't know today, after 10 days, that it has been made available, it's clearly indicates that he or she has not even bothered to go through the Slack channel. I mean, which is very unfortunate. So anyway, it's available. You would have received an invite. You should have registered. You then log in. So all that process is there. It's available on the in the announcement channel. Please go through it. Okay. So we had given reminder also for that. That we found that not many had registered even after that. So we gave a reminder. So this was sent, I think, five almost 5 6 days ago. I will just check and resend it again.
There is a question which has been answered, the working of hypercall interface in virtualization layer.
Yeah, maybe. So this was your question. So working of hypercall interface in virtualization layer, you wanted to know. Okay. Yes, it's interface between the hypervisor and OS. So as Vita has mentioned in the answer, but how it works, if you want to know the working, so basically your system call, how it works. Okay, so system call is for your OS, and hypercall is for your hypervisors, right? So because this is the interface between your OS and your machine, physical machine, right? So whenever the special requests are coming from the OS to the hypervisor, what it does is that, so this hypercalls essentially traps these special requests, and then it handles that with one module that's already implemented inside the hypervisor. So basically, the emulation part for how, so trap and emulate. So if you just remember from the lecture, so that is the function of these hypercalls. Basically, this is how it is handled. So same way the system call works for your voice. Okay, next question. I think, yeah, very basic stuff, but
Uh, Explain eye chart diagram. I'm not sure for which lecture this question is. Is Ashok, did
okay.
you cover anything related to eye chart? Or?
Did they mean I diagram? EYE, right?
Yeah, EYE diagram. Yes.
I so I diagram is basically the way of representing the zeros and one on the physical layer. So just to again revamp what we talked about that day, if you see the recording also, basically you're sending data from a network port to the other one over a piece of over a couple of cables or over optics, right? And you need to actually transmit zeros and ones, and these zeros and ones are represented using a differential signaling, a -1 volt to +1 volt, for example, right? So when you're sending a zero, the output is -1. When you're sending a one, it is +1. Now, the bit period is basically equal to the inverse of the frequency at which you're sending this data. So if you have a 10 Gbps signal, the bit period will be 100 nanoseconds, right? So when you take a 0 or a 1 for a bit period of 100 nanosecond, so that basically transmitted a 0 or a 1. Now you're sending sequences of zeros and ones, right? It can be a lot of zeros followed by ones, or 0 1 0 1 0 1, like a clock signal, depending on what serial data is going through the channel. If you superimpose every bit period's value onto each other, onto itself, for example, take the first bit period. If it was a 1, then you make the line, the horizontal axis as 1. If it was 0, you make it as -1. And then next bit period, again, you make it on the same time scale. You keep on repeating it. So basically, you will see a I kind of a pattern, which represents the distinction between zeros and ones over a time period divided into the bit period. And the whole point of that eye diagram is to represent whether when you are transmitting zeros and ones, whether you are receiving it intact on the other end or not. Because on the physical layer, there are a lot of things that we talked about. There is frequency dependence of the channel, which kind of reduces the eye height and the eye width. And therefore, your receiver cannot make out whether you got a zero or one. So eye diagram is a very important measure for looking at the physical layer qualities of a high speed channel, and therefore designing your receiver filters which can extract the zeros and ones, as in extract the original data which was transmitted even in a noisy channel.
Okay, so I can see another question from Hypervis. So basically, the question is, what are advantages of having bare metal VM and hosted VM? How to decide which one to use? Right. So, so this is very easy actually to decide which one to use. First, remember what kind of VM you want. You want a process VM or you want a system VM, right? So we discussed about broadly in the lecture. So if you refer to that, you will see that for your bare metal case. So if you want process VMs, you cannot have bare metal VM because you need to virtualize the ABI, right? So an ABI is basically the combination of the OS libraries and the ISA, right? So so you need to have one OS for process VMs. And if you want to have system VMs where you want to virtualize the ISA, that you can do with system VMs. So there you go. So if you want to decide to have virtualized ISA, so you go for your system VMs. So that is your choice. And if you want to have process VMs like JVM or any other process VMs, so you need to have one OS. You cannot go bare metal in that case. Okay? So you need to have OS, a native OS. You need to have, then only you can have the bare metal the process VM. Okay? So yeah.
There is again another question for Ashrut. So this is based on the 18th Feb session. What is the difference between deterministic routing and adaptive routing with respect to InfiniBand switch?
Okay, so InfiniBand and most of the high performance networks are usually statically routed. So what we do is we create particular kind of topology, and then there is an algorithm which finds out the minimum hop distance between a server, between a pair of server, and it populates the forwarding database of all the switches. Now, let's say if you have created a 100 node cluster. By 100 node, I mean there are 100 servers connected to an InfiniBand fabric. Then the amount of paths which will be there in the fabric is equal to n into n minus 1, where n is the number of servers. Simply put, server one number 1 can talk to server number 2, 3, 4, like that up to 100. Server number 2 can talk back to 1, and then 3, 4, like that up to 100, and so on. Now, the path that every pair of communication that can take in your topology, it's actually fixed at the starting of the network. That means when you power on the network and you power on the routing engine, that means start the routing engine creates a forwarding database and populates all the switches with a fixed path. So it is always a statically routed network. Now, this kind of network always presents a problem when you have varying communication pattern, because you may hit up on combinations. And again, it was explained in the lecture. You can maybe revisit the slide where I talk about segment sharing. So there is a lot of probability that certain application communication pattern will share some of the network segment simultaneously. And when it is sharing a segment simultaneously, it will not be able to receive 100% bandwidth. It will receive actually only half the bandwidth. If it so happens that three of the communicating pair share a particular segment in the network, then you will get one third the bandwidth. And therefore, a statically routed or a deterministically routed network, which does not change over time, has got a inherent property that it can be blocking, even though you created a non-blocking network. Okay, when I say non-blocking, I mean even if you created a network which has got enough amount of switches that every pair of communicators has got its own network path, but because of the communication pattern, it is using some of the paths more and it is not using some of the paths at all. Then you hit up artificial blocking. This is where adaptive routing comes into picture, where the networking elements, the switches themselves, are intelligent enough to see that a particular output is being used more than one time and some of the outputs are empty. It can detect it by looking at the ingress queue and the egress queue of the switching processor. And based on that, it can decide to reroute certain communicating pairs over the free links. And this is what is adaptive routing. The important part is that the elements themselves should be fast enough to react. Otherwise, there is no point in rerouting because by the time you reroute, that communication will be over, right? So there is no adaptive routing. So the difference between static and or deterministic and adaptive routing is in deterministic routing, the switching elements are completely, I would say, dumb. They have a predefined forwarding table which is fed to them. And in adaptive routing, the elements themselves are intelligent and based on what segments of their ports are being shared by how many communicating elements, they can actually switch traffic across another parallel path.
Don't see any more questions. We'll wait for more time. If you have any questions related to any lectures, you can continue posting them onto the Q&A window.
There is a question. Can you understand? I mean, is it for Ashut?
I thought we did answer all of them.
Can you read
How
it
to
out?
use
I
topology?
don't see.
How
Okay.
to?
How to use topologies?
Sorry, how can?
How to use topologies? It's, I am not completely getting the question, but how to use network topologies? I don't know what does it exactly mean. But
So
No,
network
actually,
topology, yeah, I think network topologies are a way of connecting the servers, right? How you connect them. For example,
yeah,
if you have 100 servers, you can connect it in, in a multiple switch in a tree fashion. You can connect it in a mesh fashion. So if the question is how to use topologies based on a specific application, then the answer for that would be that depends what kind of applications you're using. If the applications are containing almost random all-to-all kind of communication pattern, then the best topology is a tree topology or an all-connect topology, depending on the size. And if the application is MD kind of simulation with very much nearest neighbor communication pattern, then you can use a torus kind of mesh topology. I don't know whether that was the question, but
Yeah, if the person is can elaborate on the question, that would be great. The next question is there is a mention of 800 GPUs using PCI versus SXM. Are they two different interconnects? What is the difference between them? So maybe I can answer this very quickly. 800 GPUs, the GPUs come in two flavors. One of them can fit on interconnect which is called as PCIe, or the second option is that you can also get another version which is SXM. Now, PCI is something which is very well known, and the GPUs will basically sit on the PCI slot, giving you the respective bandwidth, which is like 32 Gbps to transfer these data between CPU and GPU. The other version of 800 GPUs, which is SXM, they are also connected. They can be connected using a interconnect protocol which is developed by NVIDIA, which is called as NVLink. Now, NVLink can provide you more GPU to GPU bandwidth. If you are working in a multi GPU environment, especially the lecture which was done, and if you would like to say run one particular model across multiple GPUs and you need to communicate more often or with a higher bandwidth, then SXM A100 GPUs can provide you lower latency and higher bandwidth as compared to using a PCIe based GPU. So you have two options. One of them is a PCI based GPU. Whenever you buy a GPU, based on the server type you have, you can choose either A100 GPU, which is PCI based, or SXM based. There is another question on what is DGX referred to in DPOPS. So DGX is basically a supercomputing server which is provided by NVIDIA. Like the DGX with can have up to 800 GPUs which are connected to each other via NVLink. So it is a server which is provided as in by NVIDIA, and it is basically as I said, it contains all the stacks that we have taught you so far, including the containers and everything inside it. And it has like eight 800 GPUs connected to each other via NVLink, and it also comes with the interconnect, which is InfiniBand that was taught to you also in case you want to connect multiple DGXs together. Professor, you have mentioned about symbolic APIs and imperative APIs. In imperative, you have discussed about subclassing. Can you please elaborate? Uh, this is for you, I believe, Professor Tejit, right? Professor Satyajit, you are on mute in case you are speaking.
Yes. Sorry. Yeah. So imperative programming, it's the way of programming, and subclassing is essentially exactly that. And it's essentially the subclassing is the way you do object-oriented programming, right? So if you are thinking your model in terms of and you can define your model as an object, and you inherit either Keras model or whatever superclass you are using, that if you are inheriting and if you are using those methods that are already implemented there, you just overload them. So this is the way you do the programming in the subclassing. This is not exactly same in other APIs. Okay, so this is just the way you program your model. Okay? And it happens so that this subclassing actually gives you much more flexibility in terms of defining, because let's say you already have some methods that is already implemented in your superclass. So that means you can overload. You can either do the method overloading or operator overloading, whatever you can do. You can actually modify a entire thing with your own definition for your particular model class that you are inheriting. Right? So that way you have much more flexibility and control over the definition of them. So that's the only difference. Okay, I think another question is there. So I think in multi-GPU already sync training, it's mentioned all replicas run in lockstep. What exactly it meant? Okay. Uh, yeah, I will take this. Bharat, would you like to take this?
Actually, I'm not very sure about the question. Uh,
Okay, yeah, so basically, if you see, I have talked about this a bit, but I have not actually explained like how actually it is working. So when you are serializing, basically when you're uploading the computation graph, right, inside your multi-GPU. Now, when you are using multi-GPU in one particular system, right, so you want to have data parallelization. So you distribute your data. So I0, I1, I2, I3. So all this stack we have seen so far. So once you have distributed the data and you have created the replicas of, let's say, the variables. Now here the variables are essentially the parameters and which you are computing the gradient for and the gradients itself, and then you update the parameters. Now let's say one forward pass is done with I0 input in one device. So there are, let's say, multiple devices. I0, I1, I2 is going, and the same model is operating in all the GPUs, right? So one forward pass you have done, you calculated the loss for particular that input, right? And you have calculated loss for I1 in another device. You have calculated the loss for I2, let's say, in another device, and so on. Now the question is, what will be the gradient update? So because you need to do the mean after the forward pass, right? Depending on all the inputs that you have given. Now, how you will do the mean? The mean you need to do once they sync all together after this forward step. So if it is not locked step, that means they will continue the next process, that is the upgradation or gradient computation. But that they cannot do until or unless that mean is computed. So that means they will wait for the mean is being computed and distributed or broadcasted to them. So once they get all the, so basically that all reduce, you can see all will send to all. So basically all will get the copies of all the losses. Then they can do the mean. So then they can go ahead and do the next step of computation. So that is the locked step in the all reduce sync training. So until or unless they sync, the process will be locked in those GPUs subsequently, which are doing the training process. Okay? So that happens in multi GPU in one node or several nodes. You can have multi GPUs. Okay? So if you are using the already sync algorithm, so it will actually lock the process until or unless you use synchronize. Then again they can go ahead. Okay?
yeah, I don't see any other question.
Hmm. I do not see any other question.
Okay, I think in that case we can terminate the session.
We'll wait for 1 more minute maybe. And
Yeah, there is one question.
no, it's actually a thanks.
Okay. Okay, I think Bharat, we can call it a day, and uh, next session will be on coming Monday. Before that, exam will be on Sunday, right? That's our schedule now. So this year they have about 6 days to prepare from today.
Yeah.
Okay. Yeah.
Okay, yeah.
Thank you. All the
Let's
best.
wish them all the best. And don't worry, don't take tension. Just thirst. If you have attended all the lectures meticulously, I don't see any reason why you will not be able to answer the questions. That's the bottom line. Okay. Thank you.
Thank
Okay,
you.
thank you.
Thank you.
Bye.